Hello, everybody. Welcome to lesson 9, where we are going to be talking about number systems, the real number family. We're going to be learning some terminology and classifying numbers. We're going to start off by filling in the blanks to these definitions. In front of you, you see natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Natural numbers, also known as the blank numbers, and continue indefinitely. Natural numbers are also known as the counting numbers. Counting numbers. So some examples of natural numbers are 1, 2, 3, 4, 5, and so on. Numbers we count with. Whole numbers. The set of all natural numbers and 0. So whole numbers. Examples are 0, 1, 2, 3, 4, so on. Integers. Integers are a set of numbers that have positive and negative whole numbers, plus 0. Positive and negative, and 0. So an example of an integer, -3, -2, -1, and so on. A rational number. So this is the set of numbers including all integers, whole numbers, as well as all numbers that can be written as a fraction or ratio of two integers. And they are either terminating or repeating decimal. An example of a rational number could be 1/2, half, or it could be a decimal, 0.75, or it could be 333, and so on. Irrational numbers. The set of numbers that cannot be written as a fraction and cannot be written as a ratio that can terminate or repeat. So an example of an irrational number could be pi or the square root of 7. Irrational numbers. If you notice here, the visual is just to show you how they all relate to each other. So all of these are real numbers, and all integers are a rational number, and all whole numbers are an integer, and all natural numbers are a whole number. In this chart, we need to fill in the missing sets for the word. So we have natural number. We are missing whole number. And integer. We have rational number and irrational number. Number 6. We know number 6 is a natural number. We know it is a whole number. It is a positive number, so it's an integer. And we know it is a rational number. The smallest set that it belongs to is a natural number. So, just to give you the visual, we're going to keep it with the 1 check at a natural number. 0. It is a whole number. It is an integer. It is rational. The smallest set it belongs to is a whole number. -8. As soon as we see that negative, we automatically remember integer. Now a decimal. Whenever we see a decimal or fraction, we think rational number. Square root of 7. That does not repeat and it does not terminate. So it does not end something. That means it is an irrational number. We have a mixed fraction here, 7 with 1/8. We can convert this to an improper fraction. When we convert that to an improper fraction, it is a fraction. So we know fractions and decimals are rational numbers. And at the end there, we have pi. Pi does not terminate. It does not repeat. We know that means irrational number. Sets and subsets. A set is a collection of things that all have a common property, and a subset is a small set within a set, using that symbol there. Natural numbers and whole numbers are both subsets of integers, and natural numbers and whole numbers and integers are subsets of rational numbers. Again, we're just looking at that relationship, how all these different categories relate to each other. And there's that little diagram there where that blue circle is the set of numbers. But 1, 2, 3, that's a subset in that bigger set of numbers. 1, 2, 3 is a subset of the set 1, 2, 3, 4, 5. In this question, it says we have two sets here. 2, 4, 6 is the set of numbers. And it's asking, is that set A a subset of this set B? 0, 2, 4, 6, 8. Is this set A a subset of this set B? What do you think? Can we find this set of numbers in these numbers? Is 2 there? Yep. Is 4 there? Yep. And is 6 there? Yep. So the answer is yes. A is a subset of B. Is the set 2, 7 a subset of this set? Let's check. Is 2 here? Yes. Is 7? We are missing 7. No 7. So the answer is no. There's no 7. So C is not a subset of B. The number of distinct subsets of containing n elements is given by 2n. So 2 to the power of a number is what that means. The set 3, 6, 9, 12 has a total of how many subsets? So let's take a look at the formula. 2n. There are 4 elements here. There are 4 numbers in this set. 1, 2, 3, 4. So we are going to do 2 to the power of 4, which gives us 16. So we know this set of numbers has a total of 16 subsets. Given this set of numbers, provide a few subsets of set C. So in this set D, set C, let's find a subset. We can choose any set of numbers in that bigger set, and that'll be a subset. So we could do 1, 2, 3. So that is a subset of set D because we have 1, 2, 3, 1, 2, 3. Finite versus infinite. We're going to just read through these definitions together. If something is finite, it has an end. The set of whole numbers less than 100 is a finite set because it begins at 0 and it ends at 99. If something is infinite, it goes on forever. Something that is unlimited, endless, and without bounds. The set of natural numbers is an infinite set. Infinity. It's a number set. A number set is infinite if it has no end and it goes on forever. Lines are infinite. A line can go on forever and ever and ever and not end. What are some examples of infinity in the real world? So, first thing that comes to mind for me in the real world, what do I think of when I think of infinity? I think of space. It has no end. The universe has no end. It's the same idea. And now when we think of density, we're going to read through this. A set, number density. A number will always exist in between two rational numbers. So a set is dense if you can find another number between two numbers. There's a number line there. Consider the set of real numbers. Would it be considered dense? The answer would be yes. Because in between these numbers, for example, between 2 and 3, could we find a number? Yes, we could find 2.5. And that means it is dense. So there are infinitely, many numbers between them. Down here, it's asking us, example 6, compare the set of natural numbers and the set of rational numbers on two separate number lines. Is each set finite or infinite? Is each set dense? Now, let's take a look. In the set of integers, what number falls between -3 and -1? If we look at our number line on the right there, let's go to -3 and -1. What number falls between -3 and -1? The integer in between that is -2. In between -3 and -1, this is what we find, -2. In the set of integers, one number falls between -6 and -5. -6 would be down here. What number would fall between -6 and -5? We can choose. Easy one to think of is what's in the middle. 5.5. 5.5 would be in the middle of -6 and -5. In the set of rational numbers, what falls between -6 and -5? So now it's asking us, when we think about rational numbers, when we think about decimals and fractions, when we think about those numbers, is there another number that can fall in between -6 and -5? Is there another decimal that can fall there? Yes, of course there is. We can do -5.25. We could do -5.75. We could do -5.15. So yes, we can list more than one. Limits. A limit is a value that is approached but not necessarily reached. A limit is a point or level beyond which something does not extend or pass. The value will approach this limit as it will get very close to, but it will not pass. What are some limits in the real world? So this is something we get close to, but will not go past. An example is a speed limit. We can get close to the speed limit. The intent is not to pass the speed limit. If the speed limit is 80, we're getting close to 80. Once you hit 80, you're stopping. Speed limit. Another example of a limit is a fuel tank. When you're filling up your gas, the gas can get close to the top. You can fill it halfway, 3/4 of the way, you can fill it all the way. But once the tank is full, it will not go past. There's an example here. In A, we have 8.1, 8.01, 8.001, 8.0001. Now it's asking us the limit. Those decimal numbers are always getting closer to the whole number 8. So the limit is 8. So in the next one, the limit is always getting closer to a very familiar number, 3.14. We know as pi. These numbers, the decimals keep going on. It's always getting closer to pi. And the last one here, this limit. We have 1, we have a half, a third, a quarter, a fifth. It's getting smaller and smaller and smaller and smaller and smaller until it will reach 0. The limit is 0. Now it's asking us to create a set that demonstrates our understanding of infinity. So an example of infinity, easy. 1, 2, 3, 4, 5. We know that will grow forever. Numbers can go on forever. And B, create a set that demonstrates your understanding and limit of 1. An example of this, we have a limit of 1. It can go up to 1, but not past 1. So we will do 0.9, 0.99, 0.999, etc. And it approaches 1. Now that brings us to the end of our handout together. We learned about number systems today. We learned about subsets, sets. We learned about finite versus infinite, number density, limits, and we learned about the real number family. You guys can go ahead now, finish your own worksheet, and I will see you next lesson.